Hello, my name is Jinsoo Choi from KAIST. This is co-authored by Tae-Hyun Oh from MIT and Kweon from KAIST, and I will present contextually customized video summaries via natural language. So what is video summarization? Video summarization is simply taking a long video and making it into a short video. So a long video can be several hours, and the short video is several minutes. So how do you make a short video? How do you make this short video? Well, this is what gives you the publications. So an author came along and said, interestingness is what's important to make this video summary, and then published the paper. And then another author came along and said diversity is important, and then published a paper. And then another author came along and then said, no, objects are the ones that are important, and then published a paper. And then another author came along and then said, no, actually causality is what makes video summarization special, and then published another paper. Our idea is we should ask the users to show what is important in the long videos to make the video summarizations. So we ask the users to make the the text descriptions, and then we allow the users, we take the user-generated text as input to produce the customized video summaries. So we select the segments here, and then this is how we make the video summaries. So instead of learning an interestingness or diversity or object or causality or anything of that sort, we learn the semantic mapping between text and video. This is done in two stages that is manifested into two columns you see here. First, we train the first column with MS Coco so that it learns the relationship between text and images. We train the MCNN and order embedding networks, which are some of the state-of-the-art semantic learning networks. Then we train the second column with the egocentric or TV episodes dataset to learn the relationship between the video and the text, which is the target task. The second column is a triplet network with pairwise ranking loss, where these video frames were converted to VGG features and the sentences into skip thought vectors. Now, when we train the second column, we freeze the weights of the first column and transfer the features generated from the first column to be added before being fed to the pairwise ranking loss of the second column. This is where our model gets the name progressive residual networks, since we first learned the semantic matching between the text and the images. So the first column and progressively learn the residual visual domain knowledge in the second column. This is the math. If you are interested, come to our poster. For evaluation, we compare the frame to text to frame retrieval results to see if our progressive residual method is indeed better than other baselines, including triplet fine-tuning, training MCNN order nets from scratch, or fine-tuning them. And we see that our training method shows better results most of the time. For main evaluation, we evaluate the video summarization results with reference summaries, and we ended up making very challenging baselines because there weren't prior works using texts. So we ended up making a very challenging baseline, and we show comparable results or better results. This is a TSNE visualization of video frames of VGG and our network. You can see that VGG clusters some clusters close by because it's a visually, because it clusters them visually similar, but ours separates them further away because it's semantically further away. Thank you for listening. Please come by to my poster. Thank you.